Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. Continuous delivery lets you get new features in front of your users as fast as possible without introducing bugs or breaking production, and GoCD is the open source platform made by the people at ThoughtWorks who wrote the book about it. Go to dataengineeringpodcast.com/GoCD to download and launch it today. Enterprise add-ons and professional support are available for added peace of mind. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host today is Tobias Macey, and today I'm interviewing Walter Menendez about the work that he's doing as a data engineer at Buzzfeed. So, Walter, could you please introduce yourself?
My name is Walter, and I'm a data engineer at Buzzfeed. Been with Buzzfeed for almost 2 years now, and it's been sort of a really good time. Mainly, I'm responsible for the construction, the maintenance, the sort of overall improvements of all of the data pipelines available at Buzzfeed that sort of then empower, sort of data literacy and sort of like data-driven decisions throughout the rest of the company. So those are kind of sort of like my biggest responsibilities there.
And how did you first get involved in the area of data management, and what about it interests you and keeps you going?
I fell into data rather kind of by accident. What kind of happened was a lot of my experience before doing industry internships in college were in the MIT Media Lab. And if you're not familiar with the MIT Media Lab, it's this research lab at MIT where at the time their mission was kind of more about sort of just playing around with different technologies and different concepts and just prototyping constantly. And so kind of my background had come from just working on a lot of prototypical technologies. Eventually, the Media Lab switched philosophies and became kind of more about deploy or die. So kind of trying to push research groups to actually produce work that would then be viable and could then be sort of productionizable out in the real world. And so, kind of a part of that transition was a lot of the projects I got more involved with ended up being a little bit more data intensive. So, for example, one of my research projects for a semester involves sort of the organization around cell phone metadata. So they, for example, this guy from Belgium, he was doing his PhD, and he was in direct communication with all of these European phone carriers, and they had given him access to all of this kind of carrier metadata that they had about when certain phone calls were being made, from kind of what anonymized ID to what another anonymized ID was the call being made to, from what cell phone towers was the call used to redirect all that signal, all that kind of stuff. So doing kind of projects of that, and then my senior project in college revolved around micro trend detection. That's kind of how I described it, where it was about trying to detect, trying to basically re-implement trending topics, kind of how Twitter does it, but doing it for very small and very kind of very specific geographical areas. So the professor in question at this time, he cared about this one town in Spain that was using Twitter to run its city government. So the mayor had a Twitter, the police department had a Twitter, the Department of Forestry, or the Department of Urban Planning had a Twitter, and you could tweet directly at all these individuals, and that would be considered a public and legal action to talk to them, and they would collect agenda items for their meetings via Twitter. So just kind of I was always around data heavy projects. And so my first internship in the industry was at Tumblr, where I was on the search engineering team. And I was working on improving the way they did trending tag detection. So at the time they were rolling out trending tags. So if you're not familiar with Tumblr as a platform, they have tagging the same way pretty much any kind of major platform does. Except that, they kind of wanted to sort of know when people were starting to all of a sudden tag a lot of their content with kind of the same few fields. And they had done kind of, an initial pass of what they kind of thought they should look like, but they were kind of wondering if there were ways to detect things even sooner. Like the latency that they had for at the time was about like a day's, worth of like behind. Like something would be, you would know something would be trending basically the next day, but they kind of wanted something sooner than that. So that was kind of what I was involved in. And so that was kind of a really nice project because it kind of exposed me to some of like preliminary data science work that you could do with that kind of stuff. So, trending tag analysis and like, anomaly detection, right? These are things that a lot of like data engineers that I know now have dealt with. But then also being able to like, productionize this, like, how do I, start writing some crons? How do I automate the same kind of few database queries that I run over and over? So when I did my internship at Tumblr, I feel like it kind of synthesized a lot of the kind of data management that you're kind of talking about before into a single, kind of like into a single like pipeline. And I think that's kind of what, got me into thinking like, oh, I think I really like data. I really like working with data, and I like working with data at scale. I think that's kind of some of the biggest things that really keep me in data engineering is that like the scale at which data engineers have to fundamentally work at is just so intense kind of from the get-go, whereas with other projects I feel like I've heard it's like, oh, they always do either it's like a limited onboarding, so they like control the scope or the scale at which they expose a product at, or whether it's like, oh, this runs offline, we'll never have to worry about breaking a production server or running out of like resources and things like that. It's like, with data engineering, it's like you have to get scale right from the get-go. And, if it doesn't work at scale, it doesn't work at all, which, it's kind of a fun problem to be tackling, on a frequent basis. So yeah, that's kind of my foray into data. It started, just through a bunch of like research projects. And then finally someone, effectively told me to do it for a job, and then I did. So yeah.
So one of the things that you mentioned that I wanted to sort of get a definition on is the fact that at Buzzfeed you're working on data literacy across the company. So I'm wondering if you can just describe a bit about what that means in terms of sort of your idea of the concept and how that translates to your actual job responsibility.
Yeah, I mean, so for me, that kind of means just being able to sort of understand like the kind of data that is available to you in terms of like if you're an editor or if you're like a client relations manager, being able to just understand like this is the data, the kind of information that we have around, this is the kind of information that we collect, that we aggregate. Yeah, and I feel like how that translates into my actual job is I feel like through just basically making our data as easy to use, as discoverable as possible. And yeah, I think it's just really those two things where it's like, really just focusing on making data discoverable and easy to access, because if your data isn't, I think it's been we've run into this a few times where it's like, all of our data kind of sits in archives, like, in the cloud, right? Like that's a kind of a really common thing to do where it's like, as you with any real-time data system, it's really common to just, save all of it, right? And that data is just kind of sitting there. But like so many people don't really know how to access that information, and they don't really know what they can do with all that data if they really just had access to it. So trying to build systems in such a way that makes that data easier to work with is kind of sort of our main responsibility. And it doesn't really translate to a sort of a really clear, concrete thing every day, but just sort of like, this is what we think of, when we're thinking about the properties of a system and the usability of a system. I think more importantly, we think more about what is the easiest thing we can make our end users do in order to get the data they want and be able to, draw the insights they need from it, come time to actually like engage with data. So I think that's what data literacy means to me. And I think it's a concept that, I think the organization also kind of sort of agrees with, mainly because it's like with a lot of the product releases that we do at Buzzfeed, it's like we don't release comfortably until we have a solid data workflow embedded into the product launch itself. So it's like, if it's something like, oh, we want to see this new product, how it's going to work, there's data for it. Oh, we want to A/B test something, there's data for both variants or every single variant that you're working with, things like that, right? So it's like that's to me what that means.
Yeah, it's interesting how the way in which data is stored and structured can really impact how people perceive it, both in terms of the utility of it as well as their ideas of what they can actually use it for. Because if it's all archived away in a database, it makes it much less accessible to a non-technical person. Whereas if you have some sort of dashboard, even just cataloging the types of data that you have with some sort of metadata about where it was gathered from, or maybe even just any sort of linkage between this data and other data that you might have available. It can just add a lot more overall value to the data capital that you have invested in the business.
Yeah. And part of that also kind of comes being like, if also being able to answer the flip side of that, being like, oh, we don't collect that, right? It's sometimes also hard for us to sort of be like, oh, like, are we collecting the data on that? Like, especially because I interface a lot with the data scientists, and sometimes they'll just straight up ask, do we have access to this kind of thing? Like, do we have this kind of data workflow already in place? And sometimes the answer is yes, we do. It's just a matter of connecting the pieces together. Sometimes it's just like, sometimes the answer is no. We straight up don't have, that we're not collecting that data, or that data is not processable in such a way that we can get that kind of information out of it. So being able to also, understand what the limitations of our current data workflows are is another big part of it.
And you mentioned having a separate team for the data scientists and the data engineers. So I'm wondering if you can explain a bit about how the different teams are structured, and if there are also sort of sub-teams within those different organizations, and the different kinds of projects that you're responsible for as a member of the data engineering team.
My team is called the Data Infrastructure Team, and we focus specifically on the word infrastructure because that's really what our deliverables are. We're delivering systems and entire architectures designed for the most efficient and the most performant transfer of data from point A to point B, right? Like, that is ultimately what we deliver to end users, and that's what they interact with. When it comes to so like that's my team. My team kind of sits directly, kind of focusing on the pipeline. So like in a way, like if you're thinking of a stack, my team kind of sits at the bottom of the stack, where we are the ones kind of like frontlining the ingestion of data into our Buzzfeed ecosystem. Kind of like one level above us, what I'd like to say is kind of the insights layer of Buzzfeed, where we have the data scientists, the data analysts, the kind of like anyone who basically has to touch data and like make a decision from it, or basically deliver kind of insights to other parts of the organization. So whether that's like, to a product team, because we have data scientists working with people doing product launches, as I said, doing kind of like A/B testing, also checking like health metrics, like, this product is great, but it doesn't increase views to the site, so it's not actually that great. In the case of an A/B test, if there's a data scientist basically being like, oh, like, we didn't get a statistically significant result from our A/B test. Like, our A/B test is no good then, and we resolve to the control instead of trying to decide that a variant is better for whatever for whatever experiment we were running. And so so it's like they kind of they are a separate team that focus directly on like drawing those insights into those decisions. Kind of adjacent to the data scientists, I would say, is also what I'd call the or what's called the learning tools team. And they build tools designed to kind of bridge the gap between like the data pipeline and the non-engineer, the non-tech person at Buzzfeed that needs to be able to understand, the analysis of their data that's coming out of our pipelines. So, for example, one of the tools that we built internally that is I would argue, the most useful thing for editors at Buzzfeed to know about is this thing called the dashboard, where it is it's a very simple rendering of a post's traffic over time. And you can see, on this dashboard, when a post was published, how much traffic it got from BuzzFeed.com, BuzzFeed the app, all the kind of like native Buzzfeed experiences, and then going to, things like, oh, BuzzFeed the Facebook page, BuzzFeed the Twitter page, BuzzFeed our Tumblr page, so, the dashboard is able to classify those kind of two things. And, often, it's not, and I imagine this won't be any surprise, for a company like Buzzfeed, most of our traffic comes from social media redirects. So being able to sort of see that breakdown and being like, oh, this particular kind of content is successful on Twitter, but not Facebook, or it's successful on only Facebook and it's a dud on every other platform. So, so that team works on building the tools and the interfaces that help editors themselves kind of make those decisions, kind of like in a self-guided way. So, so it's like, kind of like my team sits at the bottom, is ingesting the data, getting it into our pipelines and our systems. And then there's the data scientists and kind of a learning tools group that sits above us, being able to, start, processing that data, start, synthesizing it, making decisions from it. And then they reach out to pretty much the rest of the organization and the rest of the company. So both product teams, other engineers, other data scientists, and then other like editors, other client, relations managers, being able to go back to the client and say like, this is, the result of your post, this is the performance of your post, and things like that.
And what are some of the major types of data inputs and some of the different interfaces that you deal with for ingesting data into your pipeline, and also some of the endpoints that you're delivering the data to after it's been processed?
So I would say the kind of like main source of data that we get, and then the main format that it comes in, is basically through our custom like impression collection, where it's basically, from any action on, most of the experiences we control. So like BuzzFeed, again, like BuzzFeed.com, BuzzFeed, the app, things like that. We have sort of a custom, like we set up pixel tracking on the site, and we get that kind of, ingested to us as blobs of JSON, right? Like kind of very simple, low level details. And then from there, we take those blobs of JSON, we like serialize them, deserialize them as we, move them around. And then from there, we take that, and put that into, whatever persistence that we kind of have, whether it's like, whether it's a database, whether it's our archives. Sometimes there is basically there's a message consumer in the way it's ready to like, take that data, transform it, process it in whatever way, and then put that, into wherever else it's going to redirect that data, whether it's back into the real-time stream or to a persistent layer. So that's the biggest thing, basically our own custom impression information and our own custom message format. The flip side would be we collect a lot of data from our distributed platforms, to the point where we basically have an entire team at BuzzFeed devoted to collecting data from other platforms. So that's data coming from, Google Analytics, because we, as like any good development of a system, there was another system to which we could compare our results to. So like actually something that we do daily is compare our impression totals with what GA thinks our posts got, and we kind of compare to be like, okay, good, our data is good, or like, no, our data is actually really bad for this one day and we don't know why. So GA is one source of data. We also again get a lot of data from like Facebook, which comes with its own array of challenges, because like Facebook changes their API responses all the time, or they'll change the format or the semantic meanings of certain things in their message format, and as a result we'll break the ingestion of that data on our side, and that leads to some repair that needs to happen. And so those are kind of the two main sources, like our custom, our owned and operated collection, and then there's the distributed collection of data. And as I said, like to make these things exposable, it's usually either there's a persistence layer that we're shoving all this data in, and it all kind of comes through again through the real-time event stream. And then I'm trying to think. Yeah, whether it's being consumed in real time. If it's being consumed in real time, then as I said, there's message handlers set up for that, and then they'll consume that data, flush out the persistence. If it's offline, then as it comes into the real time event stream, it's just archived, and then there are offline processes that will periodically pull down some of the archives, put that information or grab those messages and start processing them, aggregating them, doing whatever it is that they'll do to them, and then flushing that result to that in whatever way they see fit, whether it's like other APIs, other like databases and things like that.
And one of the things that you mentioned is, particularly when you're dealing with Facebook, but in general, there are cases where your ingestion will start receiving bad data, or the defined interface is no longer fulfilling the contract that you're expecting. So I'm wondering, what are some of the methods that you have for validating the health and cleanliness of the data that you're ingesting, and any sort of monitoring or metrics or testing that you have embedded into your platform to be able to notify you of those kinds of situations, so that you're not polluting your overall data warehouse with that bad data for a while before it surfaces that there is a problem?
Yeah, so kind of as I said, we basically constantly compare systems. And that being said, we start with kind of a system that we, have relied on and, battle tested to say this is correct, kind of regardless of what happens. So when it comes to the raw ingestion stream, we've compared that against Google Analytics, so that we've seen there's an acceptable like variance between the two systems. We'll never get it quite right, because there are some things that GA does that we don't, and vice versa. Like I think it's like 1 or 2%, 5% basically is what we said is the difference. Like for any given article, like these two systems only should diverge by like 5% or like if that at all. So going off of that, then when it comes to ingesting things like distributed APIs or even our own data, because as teams like adjust message formats, which happens a lot based on if they're working on a different part, a different part of the product on like Buzzfeed.com, and say they are focused on just changing some, like adding information there. Like there's also that kind of information where it's like, they could break our own ingestion, without knowing. So in terms of validation, yeah. So like we'll compare systems. If we're all of a sudden being like, oh, hey, all of our Facebook traffic is down, does that make sense? And then we'll go back to the raw data and we're like, well, no, we have this much raw data for Facebook, but we only ingested this value. Clearly our ingestion of it was wrong. So that's how we'll roll out that kind of thing. For kind of like longer term things, we have a lot of anomaly detection in place as well. We use Datadog a lot to emit metrics that of just like the volume levels of various things. And so as you can imagine, like with a website that is dependent on just kind of like natural user views, like the traffic wave is kind of, it rises and falls, with the day as people visit the site, people, then end up busy and things like that. So it's like we expect a certain pattern. So we have anomaly detection set up around when the pattern starts breaking and starts deviating. And so we're like, aha, all of a sudden we're seeing that we're getting too few events of this kind. We should ask the producers of that kind of data, being like, hey, like, are you no longer sending this data? Have we ruled out that we've broken the ingestion of that data? And or it's like, or like is the data just coming in malformatted? Like, is that an issue as well? So yeah, so I would say that those are kind of the two biggest things that we end up doing, is that we end up just comparing notes across the entire across all of our pipelines, and then ultimately just saying like, is this what we expect at kind of like in steady state?
And you mentioned that the main core of your system is a real-time ingestion pipeline. So I'm wondering if you can sort of enumerate some of the overall platforms and tools, as well as the languages that you're using most widely across the team, and then maybe identify some of the outliers as far as languages or tools that you use in sort of custom edge cases.
Yeah, so I'd say actually like Buzzfeed Tech is actually a really big Python shop. We love Python. We think it's a great language to work in when it comes to, working with data. I mean, obviously for a number of reasons, Python is very easy to write, it's very easy to read, and it's very easy to learn as well. At BuzzFeed is the kind of place where we have people working with data that come from all different levels of kind of like tech background. So like some people are coming in as like, they've been an engineer for a while. So like, they speak tech, they are fluent in, conversing with like in an engineering language. Whereas some people, they're switching careers at BuzzFeed, and they came from finance, or they came from the arts and things like that, and they're now switching into like a technical role here at BuzzFeed. So Python is such a nice way to bridge the gap across all these different levels of experience, where then we can all of a sudden to kind of communicate with the same like tools, because we're all working in Python. And obviously Python has a lot of like data oriented packages. Like, I mean, NumPy, powers pretty much like everything when it comes to sort of anything data intensive. SciPy is used a lot. There's obviously like NLTK, like pretty much like any of the major like machine learning and like natural language processing, like packages that are in Python, like we've used most of them. When it comes to actual, like, again, back to like actual data work. So, obviously Python is great, but then, occasionally we will run into kind of like Python's performance limits where we're like, we just wish this were faster. And we know it can be faster if we just weren't in Python. So, when we hit that kind of wall, we actually switched to Golang, and we have a few systems written in Go. And, that's kind of like seemed to be like a really standard pattern. It's like, we'll prototype in Python, we'll reach maturity in Python, we'll start evaluating performance, and if we can't get it out of Python, we'll get it in Go. Because we think, it's a really nice language. It's designed for, concurrency, and kind of like it was designed for servers, right? So, and, that it's kind of like loosely typed, but like, in a way, it kind of like almost like writes like Python, but like reads like a strongly typed language, at least like, when in my experience in working with it. So there's that. In terms of technologies, so our kind of like messaging queue system is NSQ. We like NSQ a lot, again, because it's written in Go. It's highly performant, and it's meant to be distributed. It's meant to not have a single point of failure, which is really nice for us. And it's so easy to set up and so easy to use that, for us, it kind of was a no-brainer. And then So that's kind of, what's, powering our message queuing as, all around the place. And when it comes to, consuming that data, and when it comes to just, quick, lightweight APIs around data, we'll use Tornado as our asynchronous framework of choice, which is really nice because then we use that for APIs, but also for our message handler. So, we use obviously the Python API for NSQ to start reading messages. And from there, it's really easy to spin up the consumption of a message based on Tornado's kind of asynchronous framework. So we'll just kind of use the IO loop to periodically ingest, to periodically flush, to transform the data and put that into persistence. So some of the main technologies are in that.
I find it interesting that in that whole list, you didn't bring in any of the sort of major hitters that most people would be expecting, like Spark or Kafka or anything like that, sort of the JVM-oriented big data tools.
Oh, yeah. I mean, so we do use those. So we actually use Spark a lot. We'll use Spark as part of our kind of MapReduce, open framework of choice. It has a Python interface, which is, again, kind of like the theme, right? PySpark is really nice. And I mean, it's a bit of an arbitrary choice also, right? Because, it's mainly for the language availability that it has, less so than the framework. But, we'll use Spark on EMR hosts in AWS a lot. So when it comes to, it's like writing the job, we'll deploy that, to a remote AWS cluster. We'll configure the cluster, start running the job, and then put those, results back into S3 and interact with, the output of our data that way, which is kind of where our archives also live. So it kind of makes sense that all our data is in S3 in that kind of sense. So yeah, there are some of these. There are some of the heavy hitters. But yeah, I mean, I feel like, after a certain point, it kind of almost goes without saying.
Right, fair enough. And what are some of the most significant challenges that you face, both from a technical and an organizational perspective?
I guess one organizational problem that we kind of have is just the speed at which user needs kind of arise. Basically, and this is kind of, I guess, a side effect of the way that Buzzfeed is kind of set up, where Buzzfeed is a company where the company itself is constantly, refocusing its business strategy, it's refocusing its models, and it's basically trying to adapt and, be kind of, the sustainable media company, for the future. And which is kind of really cool to sort of see a company adapt in real time so much. But that being said, as the company adapts, so do our, our data needs, right? Because we need to, if we're adjusting to new platforms, we need to know how the data ecosystem works on that new platform so that we can ingest that data. Or if it's we're going to change focuses on maybe we don't care about, this one metric anymore, and we care about this overall, this different thing, setting up the data for that. And the biggest way that we'll hear about this kind of thing is through our end users, where they're directly saying, oh, we need this now. We don't need this anymore, we need this. And we're oh, okay, well, fine. And as part of that also, performance issues comes out where we're saying this system doesn't work as fast anymore. It's there's too much data in it. And as a result, we can no longer satisfy our end users just as well as we used to. So a big issue with this was we were using AWS Redshift for our long-term data warehousing solution, but we just kind of found that it's the more data we kind of put into it, because we were collecting a lot of really granular data, and one table basically got to several billions of rows within a month of just periodically populating it. So we found that it's just after a certain point, querying it just proves completely unacceptable. Queries would take 10 minutes when they used to take 2, and that just it just led to such a slow workflow on behalf of our end users that things like that, they were begging us for we wish we had something better. And so being able to basically adapt to those things as soon as we can is kind of our biggest challenges, when it's how can we do this in such a way that is both not super disruptive to our overall infrastructure, but at the same time delivers the data that they need in a efficient way, and in a way that makes sense for what they're looking to get out of it. So disrupting ourselves is I guess kind of what that sums up to.
And with the need to have an eye on the ability to constantly re-implement or re-architect portions of the system, I'm sure that must lead to a certain accrual of technical debt. So I'm wondering if you can identify some of the areas in your system that have sort of acquired the most amount of debt, and some of the techniques or approaches that you're using to try and mitigate that.
Yeah, I mean, I'd say that for us, our debt kind of just comes from there have been just a lot of systems that we worked on, and like a lot of the systems that, that we initially built as a team, they were meant to solve one problem and one problem well, which, if you're building a new system, like that's kind of what you were going for, right? Like this makes sense. Like it makes sense that you were optimizing for like a really specific use case, if you were going to build a system for this like at all. So that being said, so an example of this is our kind of like wrapper API around the real-time event stream, where we built our system to collect. Originally, it was meant for only impression collection, right? Where it's like you would go to BuzzFeed.com, you'd visit something on the site, a pixel event would be fired, we'd collect that, and that's how we knew that you visited this post and like when and like collected some metadata about the visit. So at first that's all it was meant to do. But then as more and more teams kind of heard about, oh, there's this like system that I can like publish a message to and then consume it on through another thing, and it became a pattern that a lot of other teams started propagating through like setting up a stream, setting up a message handler to read from said stream and just like be able to start that pattern. And we were like, oh, this is awesome. But then as the number of teams that started onboarding more and more inter-service communication on it, as more teams started doing that, we were kind of in the situation where we've created basically a very fragile system where if as the result of like maybe rogue behavior from the system, like hammering our ingestion and maybe, leading to a, ingestion outage, they not only take down their own service is like they take down their own service like intercommunication, they take down the intercommunication of other services, and then more importantly they take down our impression collection, which is our business, right? So effectively the biggest thing that happened here was this, like the system was not designed to be able to handle all these things in its initial conception. And so, by the time we realized this, it's like a few like kind of like outages like this happened where, thankfully it never happened in a production outage, but it was like we saw that, with a staging instance, for example, like there was a system that because of the so many messages they had sent to us all at once, they managed to crash a node, and there was some minor data like outage there. So that to us was kind of, a sign that it's like, this system clearly has developed another need, and needs to somehow better address this. So, I mean, obviously addressing tech debt comes, in various forms. Like, throughout Buzzfeed, there was a point in time, I want to say like about last year, where we just, went heads down and got rid of a lot of tech debt, and a lot of this honestly just came in the form of big red diffs. Like and I'm a big fan. I think I forget who said it, but it was someone that I kind of respect and admire that said basically red diffs are good diffs. And so the number of times I saw just a pull request that was just like a sea of just red diffs where clearly it's like we don't use this anymore, there's no reason for this code to still be alive and running. So that was kind of the biggest thing that kind of came, being like just axe it, just get rid of it. So that's definitely something like one thing that we kind of being like if this service doesn't need to send these messages, just don't. But obviously in the particular case that I'm talking about, obviously that wasn't the most acceptable solution. So what we did was we were like can we somehow divorce these two, like these kind of two use cases from the same system? And so that's kind of what we ended up doing more, where it's like we recognize that we still need we need to still be able to empower services to kind of like intercommunicate themselves with this like asynchronous like message based pattern, but at the same time we still need to be able to collect impression data and have failures of either two systems be independent of each other. So we split the two systems. So we effectively created two separate ingestion points for those kinds of data, such that if you do hose us on one of the two, you don't affect the other, and we can proceed to ingest data kind of like completely oblivious to the fact that there is someone being a bad producer. So yeah, so it's like, but yeah, as I said, like it it didn't really, the thought of this didn't come until kind of like too late, when it's like we realized that so many people had done this that it was almost now a rampant thing. So not much we could have done at that point other than address it, being like this is a use case that we now have to sort of seriously consider and put some architecture behind it.
And counter to some of the sort of difficulties that you've experienced, what are some of the most successful projects that you've been involved in, and what do you use to measure the success of a project like that?
Talking about, again, our Redshift woes, when it came time to, we kind of thought like, how can we improve this? We turned to we turned to Google, basically. We started using more and more of the Google Cloud ecosystem, which ended up just being, such a better move, mainly because the way that just Google writes software, it's faster. Like the number of times I've seen, I've done kind of like the same operation where it's like, oh, I just want to like upload this file, or like, oh, I want to, populate a table from from a cloud file. Like, just the performance boost on Google's behalf it was so significant that it was kind of like, wow, we should have been here like years ago. Yeah, so like, we basically started taking like, how can we slowly but surely take our data warehouse and basically migrate all of it into a different cloud storage provider. And so I think that was kind of one of the biggest thing, I think one of the most like impactful projects of late that we've done, where being able to, move all that data and have that accessible in a more performant way for end users was kind of the biggest thing. And I think, the performance measure for success there is end user satisfaction. That we had like a wrap up meeting, and, one of the data scientists that they said, where it's just like, they said this literally just works. Like, I have to do so little thinking in terms of being able to, being like, how do I tell the system that I want this data? How do I tell it what it looks like? And then it's performance, like, expectations. It's like, it's so straightforward. And, and really that, so it's like, if our end users are happy and they, are just so, if they're having just such an easier time for them to, get access to this data, that is truly their measure of success. And I think that's a really kind of important thing across a lot of kind of like data work and data management, as we've kind of said, where it's like, ultimately your data is meant to be used by someone and to be used like for other people. And so if there is no user-centric like concern at, during the process and during the kind of development and maintenance of the system, then, ultimately, really, at that point, you're just actually serving either just yourself or the computer. Like, you're not actually servicing a human at that point, which I think is a really important thing when it comes to data, because really, data is just numbers. Data is just moving all these, like, blobs of information back and forth. And it's like, machines are unintelligible to that unless you start telling them to be intelligible about it. But when it's really, it's a human that ultimately needs to, sit down and actually look at these numbers and, draw meaning from them. So, yeah, so I'd say, like, that are kind of like, a humanistic approach to, as if they're happy, we're happy.
And are there any other subjects that you think we should talk about before we start to close out the show?
I'm looking at your list of questions. I don't know, I think that was kind of a big that BuzzFeed is hiring. I mean, yeah, it's funny because it's like the number of times where we're like, oh, we're looking for data engineers, and I hear that a lot, and I'm like, okay, I get that. And then I'll get recruiting emails about, people being like, oh, we're looking for data engineers too. And it's funny to me just how so many companies are looking for data engineers. And I think very few of them actually understand what they're asking for. And not to say that they potentially, not to say that they don't have, real data needs, but I'm saying, so few of them I think are really sort of aware of like what they're asking for, and they're just kind of saying like, oh, we have data, come engineer it. Like that's such a meaningless ask. but it's sadly the kind of pitch I hear a lot. But it's like, I think at BuzzFeed, where it's like, we do have very established data needs, and our entire culture and our entire business is around the data feedback loop that we have on our content, on our traffic patterns, on our user engagement. We have data centered on all of this, such that, it's like, data is really the reason BuzzFeed the business and BuzzFeed the company are what they are today. So, at BuzzFeed, you'll do real data engineering. And at another place, I don't know what quite exactly you'll be doing. So yeah, like buzzfeed.com/about/jobs, that's where you'll find more about what we're hiring for and what our needs are.
Yeah, it's kind of funny how certain industry trends will start to surface, and so then every company decides that they need to hire somebody with that new fancy job title, even if it might just be a slightly different permutation on something that people are already doing that they don't necessarily properly identify. And another trend as well is that it seems a lot of companies, once they do see that there is sort of this new kind of position, and they will actively seek external candidates without necessarily properly identifying internal candidates that they can train into that new position as well. So for anybody who is out there in a company who thinks that you do need a data engineer, maybe start looking internally as well before you expend all of your energy trying to bring on new talent.
Yeah, and I would say like naming is like obviously it's a very hard problem. Like naming is I mean there's a reason naming is such an issue that we always gripe on. But I thought it was really funny. Tumblr actually had a really cool job title for what I think was just basically like a dashboard builder kind of job, like after the fact. But it was like they called it the weapons engineer because they were talking about how it was part of like this, like the content spam and intelligence team. And they were talking about how the kinds of problems that social media sites had, like Twitter, Facebook, Tumblr, I think Google was another part of it. It's like there was like a small group of like really, really prominent social media companies that were having these problems. And they were saying that, yeah, it's like, being able to understand these things and being able to like, quickly address them in real time, because obviously they don't want spam on their site. They want to shut that down as soon as possible. So they were like, we're weaponizing our insights in such that way. And so we need people to build the tools around that. But really, yeah, it was just like, it seemed like a dashboard engineer job. Well, so I was like, cool job name, but pretty standard job actually. So naming these things is hard. Understanding the thing you're encoding in the name is hard. And like the number of people that have talked about being like, I don't know. There was an article recently talking about how it's don't try to be Google. Like even Google can't be Google. Like in terms of talking about like a data need about that was kind of coming up, and I thought that was really funny in terms of it was so meta, being like, oh, so it's like in short, no one really fits this canonical definition of data engineering or with like the scale of your company, and so like it's like, well, if no one's doing it, then what is everyone actually calling it? But a more philosophical conversation for a later time.
Yeah, and on the note of training people internally, there's a great talk that I'll link to in the show notes by Jez Humble from the sort of DevOps camp about the idea of, don't try to hire a DevOps engineer, build them. And I think that's still relevant to the idea of data engineering as well. So I'll be sure to add that to the notes.
For sure. And I think I agree with that, mainly because I am a product of that. I graduated from college. I just was a software engineer. Like that's what I was kind of looking to be. And having again worked on so many different kinds of technologies, it's like I had like what I would like to consider like a big breadth of things. And it's like I didn't I had some inklings as to what I wanted to do and things like that. But then like I ultimately went with the data team at Buzzfeed because I thought it's like I like data. I like the things you can do with data. I like the scale of data, so I'll stick with that. And then, yeah, like ultimately joining as a new grad, I pretty much knew nothing about data itself, like data engineering itself, right? Like there was very little I kind of knew up front, but there were kind of just a lot of general principles that I felt like still applied in terms of like, when you're thinking about a system's properties, like its fault tolerance, like its latency, its overall recoverability. Like, does the system self-heal? Like there are a lot of like things about these systems that like that they just kind of address themselves or they present themselves in such a way that like they could be about pretty much any other kind of system. It just so happens that there's data that's really sort of the core export of the system. So there's a lot of, just general principles that kind of apply regardless of really what you're building. And I think that is just like, something that is definitely just learned on the job. So like, yeah, and I definitely have learned a lot of that, in my time at Buzzfeed. So, and not having known much about data engineering at the start was fine.
All right. For anybody who wants to follow what you're up to and see some of the things you're working on, I'll have you add your preferred contact info to the show notes. And with that, I'd like to thank you for taking the time out of your day to join me and tell me more about the kinds of work that you're doing and some of the tools that you're using at Buzzfeed. It definitely sounds like an interesting set of problems to be tackling.
Yeah, thank you very much for having me.